Hello, everyone. So, in this session, we are going to understand EDA, exploratory data analysis, using univariance analysis, right? So, first of all, we'll try to understand how many data types do we have in data analysis field. So, broadly, any data has been categorized in two types, which is numerical and categorical. Numerical, also call it out quantitative, where data represents in a number. Categorical, where and data categorical type is also call it out qualitative, and it represents text basically. For example, gender and fall. For example, um, day or night, right? Fail or past. So these are the categorical uh, data types. And under numerical data types, we have discrete or interval. We call it out discrete numbers. The numbers, for example, which are fixed, means number of students in a class and workers in a company. These are the discretes, and we are having continuous data types. For example, it's always doesn't represent a fixed amount. It is kind of variable, right? So height of a person, it's not a consistent over period of time, and room temperatures, right? These are the continuous where you will be having three height of a person is 5.5, 5.7, 5.6, right? And similarly, temperatures, room temperature, sometimes it will be in points. It will not be exact always. Then in categorical, we are having nominal and ordinal. So in nominal, where order doesn't matter. For example, gender, male, female, colors, red, blue, green, it's all order doesn't matter. But in ordinal, where order matters, for example, grade A, grade B, grade C, ratings, right? You're giving ratings. So ratings will be fall from one. One is very bad, and 10 is very good. So these are the data types at high level. Uh, so, based on the data types in any given data sets, so in data sets, we will be having um, many columns, and we can perform analysis uh, all over data sets, all data set columns and its data. But mostly, what we do, we perform analysis on a particular column. Okay, and in that sense, when we perform any analysis or any exploratory analysis on a particular column, then we call it um, univariance analysis. So we will in this part we'll perform univariate analysis, and we'll learn how do we perform that on a particular column. So to start with that, I'm importing pandas and Sivan libraries, and this is just I'm loading my um, train dataset. So for example, I have shown here. So this is the one of the um, Titanic datasets, which shows that okay, passenger IDs, it got survived or not, what was the P class, what was the name of the passengers, and the sex of the passenger, age, sibling and spouse, if they have with them. So one means yes, and zero means no. Uh, Parch, it's a kind of coach, right? And uh, the this is ticket number. And this is what the fare they have given, and cabin it's been allotted, I think, for uh, class 1 people has been class 1, class 2. I think they have been allotted with cabin. Class 1 or only class 1 or class 2. Embarked, which station it has they have onboarded, right? And so in this data set, we will be having categorical data and numerical data as well. So uh, we will be, and most of the visualization we will be doing on categorical and numerical both. So in first we will understand categorical data uh, analysis, how we should be doing. So in categorical data analysis, as we know, categorical data represents like for um, uh, pass, fail, or survive, not survives, male, females, right? So on those we can perform univariance analysis. So just to see how this analysis looks like. So here um, I we have this data frame, and what I'm doing, I'm getting all the counts of the survives, and I'm saying that okay, plot these counts, and it's kind of bar, and use the color red and green. So as in our data set, we are having two type, right? Survived and not survived. Uh, so uh, this one red shows survived. Sorry, one saved survive and zero save shows not survived. So with this data set, we are able to analyze that, okay, it seems like near about 600 uh, we were not able to survive, and approximately 350 got survived, right? So with this, we are able to conclude. Another way is to do this count plot um, to show the counts based on the embark, right? So how many people embarked uh, on each station. So here we are able to see the embark has been done from Xiong. Okay, so let me bring this one embarked data set. Okay, so here you can see that Shebog and Q question, Questown, and Southampton. So in this survived, we are able to see Southampton in England. We are seeing uh, highest number got onboarded, and then uh, Sherborne, yeah, Sherborne, and then Southampton. So right, so this is again the same plot. I shouldn't be using this. Right. And next uh, way of exploratory analysis we can do in terms of pie chart. So for pie chart, if we would like to see the distribution of shakes across the data set. So in this case, for example, I would like to see that, okay, whole data set, what was the ratio of male versus female. So I would be able to see clearly. So I'm able to see 64.76% were male compared to female, right? And same, I can see between uh, classes as well, right? So, for example, if I would like to see uh, each clash, right? So each clash are P clash. Okay, so I should be able to see similar distribution and P clash as well. So if I am seeing the clash wise, so I can see uh, clash 1, 2, 3, right? Here we are having class 1, class 2, class 3. So here I can see that, okay, in class 3, there were too many people, and class 1 and class 2 were nearly equal, right? And the way this 6 also. So this is the chart way of exploring the data, and this is for one variable, right? And this is called univariance analysis. Then second, earlier was for categorical. Now we can perform the same thing for numerical data as well. So univariance analysis on numerical data will run. So for numerical data, one analysis we do often is histogram. It is quite important. So histogram is a graphical representation of distribution of numerical data. So what it does, it helps to understand, uh, to show us how data is spread, if, a spread overall, and where the most of the values falls, right? So this one helps us to understand distribution. Um, it is normally distributed. It's skewed, or it have uh, uh, bimodals into data set or something like that. And it also help us to identify how much data are outlier and which are data are probable to outlier. And also it's yeah uh, did show us the skewness is which side, left side and right side. And also it's shows us data concentration, means where most people uh, fall. So for this, we are going to include matplotlib, right? And with plotlib, we are going to uh, draw a visualization on age. So uh, here, based on the five bin sizes, so these are the sizes of width of this bar, and it displays that population uh, getting included into it. So with this, we can see that, okay, between 15 or 18 to 30 or 35, we were having highest number of people, right? And then gradually we are seeing then second one is 35 to near about 50, 45, right? And then from then we were having number of folks from uh, 2 or 5 to 15 years of people, right? So this is how we can do analysis in this histogram plot. So another way we can do it, for example, we can change these bins, and we can do visualization in more granular way. So for example, I will have this bin size 15. So if I'm contracting in a very more granular, for example, 15, if I am saying that my bin size is 15, means it will be uh, covering less age group. Okay. And in that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hence, all the data set has been divided in 15 uh, bins, right? And then if we are seeing, so here we are seeing uh, the highest number from 5 to, it seems like 2 to 5 years of age compared to 8, compared to 5 to 10 or 12, right? So this kind of analysis we would be able to do by changing the bins. So different sense we can explore from the data sets, right? And this is again, if we are doing 5, uh, so this is how this data is giving us a sense at high level. And next one visualization is displot. So this plot is a function from Seaborn library itself, and it shows the distribution of univariate uh, uh, univariant variables. So what it does, it's a similar to this uh, histogram, but it draws the lines uh, uh, across, right? So what it does, it checks the distribution shape. So it's just defines the distribution shape, and it also helps to outline the outliers and uh, compares the distribution. It can show us that where skewness is too much, right? So this is the one. It shows us. There is a this plot. So this plot is about to deprecate. We are having library, uh, different libraries. So that's where it is displaying. But here you can see. So you will be able to see that, okay, uh, this was age distribution, and this is how towards the age this group of population is getting distributed. Next one for univariate analysis is univariance analysis. We usually do with box plot. So it shows the distribution of numerical variables, and i- i- it's a source. It's a central value and spread an outlier. So, for example, what it does, it's divides uh, whole data set in quantiles, right? So quarter one, quarter two, quarter three, right? So uh, so this single dotted lines, first part shows the minimum quantile. So these are the uh, data sets which are very less, and in Q3 side, whatever data we are getting, that will be uh, very uh, far from other uh, group of data sets. So in a distribution, we can see that there will be left side, which will be too far, in it means the negative side, and positive side. Okay, and center one is mostly shows the median areas where most of the population lies. So with this distribution, we can say that okay, left side and right sides of the population which are too far, those would be the outlier. So it helps us to see the data spread, right? So it's visualizes as where min, max, and medians are in, and also it shows the interquartile range. So all these three we can visualize easily in this box plot, and also it helps to detect the outlier. So it points outside. Uh, uh, Whisker are likely outliers, okay, and it helps to compare the distributions. So it compares across the categories. For example, male, female, also different categories we can compare together, and uh, uh, it helps to identify the skewness where more data is skewed, right? And it helps to see the quick summary of data. So multiple distribution in one chart. So this is one of the box plot, and here you can see um, it is showing how age is distributed, right? So for example, if I will say X, then uh, this will be uh, yeah, X-axis wise distribution, which will be similar to this box plot uh, depiction. So here we can see that most of the population lies between 20 to 40. Okay, and rest of the uh, uh, are within this range. So from 5 to this, and 5 from 65 up to 65 or 60, yeah, 63 or 4. And outside of that, we are seeing 80 and all that. So it might be, it will not have that much impact to our decisions maker. So this one can be neglected, or this can, if we are including this data, it can uh, bring the skewness in our calculation. So with this, we can see and we can find the uh, outliers. Okay, and for example, yeah, this is the mean. If we would like to check, so automatically mean and max, it's getting calculated. So mean is point and we did 4, right? Max 80. So here you can see maximum is 80, and then again, yeah, again this is the mean itself, mean of age. So we are able to see mean of age uh, is data frame age is this much 29. So this is the minimum value we are having in this data set. This is maximum value, and this is the mean of this uh, data data distribution. And skew, so we can see that this much is skew. This data has this much skews. So this is this way we can do univariance analysis for numerical and categorical data set, right? Next, for exploratory data analysis, we should be doing bivariance or multivariance analysis, right? So in this analysis, we will be considering more than one column. in our uh, analysis, and we will find the correlation and how those two are correlated and impacting each other. So in this analysis, we will be using multiples uh, tools, visualization tools, and also analysis way. So here we are going to take these tips data sets. So these tip data sets tell us that what are the total amount of bills and how much tips they have given, and the restaurant data sets. This is the restaurant data set, and in that uh, the guy was a male or female, he or she was a smoker or non-smoker, and which day people came and what was the timing and how many people were together dining uh, people. So this is the overall data sets. Now we can wait the loading Titanic data set as well. So that we will do with respect to Titanic. And also this is the flight data sets. So flight data sets is nothing but it shows that year and month how many passengers traveled. So this is the flight data set. Okay, and next data sets we are having iris data sets. This is also one of the most popular data sets. We can find it out. So this data, all SNS uh, library data set, we can find it out. So this iris data set uh, tells about all the uh, species, and so it's very common data sets. It is available in Kaggle and all that. We can find it out. So it all the species, and it says that what is the petal length, is petal width, and what is petal length and petal weight and species, right? So this is the iris data set. So in this multivariance or bivariance, so when we do bivariance means when we are doing analysis with respect to the two column, right? And in this two column, there could be the scenarios. Both columns are numerical or both columns are categorical, right? Or there could be a scenario that one column is numerical and another column is categorical. So three kind of combination we will see. So we will see numerical bivariance analysis. And when we have numerical analysis, uh, we uh, do scatter plot just to see that how the data set is distributed. So here we are going to see relationship between total bills and tips given, right? So x-axis shows that total number of bills, total bill amount, and y-axis shows the tips. So as we are seeing that as the number of amount of bill is increasing, similarly the tips is also increasing, right? So so this person given that amount near about uh, $40, and it has given near about uh, 7 point something dollar as a tips, right? So mostly with this visualization, we are able to see that total bills and tips are having linear relationship, right? So is dot is representing each person. Then we can do uh, multivariance analysis. This is analysis with the two, but instead of bivariance, we can do multivariance. We can include more column. So in the same scatter plot, I'm going to say that, okay, this is on x-axis, so the total bills, y-axis tips, right? Now you show the sex, means the person was male or female. So here in this plot, if we are running, we are able to see that, okay, I it seems like up to here, whoever male and females are, they are mostly uh, within this range, right? So who's were taken a high uh, yeah, are paid the higher bill were male. Female were less compared to male. And in the giving the tips also, I think male are dominated, right? On the higher tip side. So this is the one analysis. By visualizing this data, we are able to do. Second, if we would like to see the smoker, right? So we can include a smoker who's were a smoker. So in this data sets, uh, use is sex and a smoker here detects dot detect a smoker, star detects non-smoker. So here you can see that in this categories, uh, in a female side, we are having very less smoker. And here we are having, uh, as we are moving up, we are able to see more smoker here in the male side, right? So this is how distribution we can do with the multiple columns and see that and visualize and build the intuition of that data set. Right. Now we were having size, right? Size was telling us how many people were uh, with that dining, right? So here, if we would like to include, we will be able to include and see that, okay, size 1, 2, 3, wherever we are seeing a small dot, we were having a uh, smaller dot. So mostly we are seeing wherever we were having higher bill in this area, right? We are getting more number of people with that dining, right? So this is one intuition we are able to build from this data set distribution and visualization, right? Similarly, let's go to understand Titanic one. So again, this is Titanic data sets, and with with the same Titanic data sets, if we are having a scatter plot between total, uh, yeah, so we should be able to see the distribution of the Titanic data set. So Titanic data set we haven't seen. Okay, we'll use it in next one, bar plot, because why we can't use it? We have to see that a scatter plot is mostly getting used in numerical type of data, right? So numerical, uh, wherever we are having more numerical, it's good to use a scatter plot. Bar plots, where we are going to do correlation or correlated analysis between two column, where one column is numerical and one column is categorical. In that case, we should be using bar plot. And here, let me remove this data set. So in this bar plot, uh, we are getting this Titanic data set, and simply we are saying that, okay, you plot the bar between uh, classes and age. Okay. So, and we given this data set Titanic one, and this is petal. So petal shows the color, how many colors we can say here, red, green, blue mostly, uh, uh, 12 colors we can get it. So if we have petal sets 1, 2, 3, something like that. So here we are able to see class and age. We are seeing that in class A, class 1, we were having more A's people, right? Class 2 and class 3 were less aged people, right? So this is how we are able to do uh, the analysis for these uh, multivariance or uh, bivariance analysis, where one is numerical and one is categorical. So in that case, bar plot is useful to use, right? And similarly, we can do the analysis between P class and fair. So we are seeing that class 1 fair is too much compared to class 2 and class 3. So there are very less differences, the prices of class 3 and class 2, but there is huge difference between class 2 and class 1 fair, right? And among um, so that was the bivariance analysis. How about multivariance analysis in uh, numerical and categorical? So we are able to see P class, age, and hue. We are defining sex, right? So we are seeing that in each class, the number of females and males. So with this graph, we are able to say that number of males were more compared to female. So here also we are able to see that uh, uh, because uh, totally it was going beyond 50 and 60 of age. So we are able to see near about 40 of age we were having in uh, class A. and 35 up to 35, mostly 35, we were having class B. Okay. And similarly, this distribution for class 2 and class 3 as well. Now, in numerical and categorical sense, we will see a box plot, right? So in the box plot, we are knowing that how this box distribution looks like. So this is for one variable, one column analysis, right? So we are able to see that, okay, most of the population falls between age of 20 and 40. But how about two columns? So we can include two column. So in x-axis, sex, and y-axis, age. And in that case, we are saying that to draw the box plot. So here we are able to see that most of the population falls under 20 and 40 are for male, and for female, most of the population falls less than are across 35, and we were having less than 20 years of age of female as well, mostly falls under this. So this kind of analysis we can extract from this box plot, right? Now, uh, again with this Titanic dataset, we can do a box plot between class and fair as well. So let's see how the class and fair uh, have a correlation. So this is the class 1. So class 1 fair and class 2 fair and class 3 fair. So mostly class 1 fair lies between somewhere around 40 to uh, 90 or 80. Here, compared to class 1, most of the fairs were below that. And uh, and here, mostly compared to class 2, the less population were in class 3, and it seems like uh, there uh, they were mostly grouped lower than class 2. So this is one intuition we can extract. So here, if we would like to check the male, female, and their age box plot, and based on this, and who were survived, right? So in male categories, we are seeing that who were having a more age, more they mostly got survived, but where few of the men's lesser group age were not survived. But you will see in female category that higher age means from 20 above onwards, they got survived. But lesser one were not. Means there were more focus on female to survive, right? So this is an interesting story here, uh, saying that higher age in women have uh, s- survived more compared to men, because intuition is coming out. Most of the people focus to help them, but higher age of male were not able to walk and move faster. They they couldn't survive. This is the one interesting story we can extract from this visualization, right? So in so we were having this one numerical categorical box plot, and similarly we can have a numerical categorical distribution. Our visualization is this plot. Mostly this plot is uh, getting deprecated, but this is one of the Seaborn library to visualize the distribution of univariance or uh, uh, numerical data, right? And it seeks the uh, normal data distribution is skewness and outliers, compares the distribution with U. Uh, so, for example, uh, here we are trying to see filtering out. This is who were survived, and we are getting their age. Okay, so we are extracting from Titanic dataset who got survived, not survived, their age. Okay, so this is uh, we are getting all the not survived age, and then we are getting who are survived and distribution against age, right? So from this graph, we can see that green one is survived. So we are seeing up to 20, from 5 to less than 15, up to here 10, compared to not survive, survival chances was more, up to 10. Means for kids, the focus were more. And from here, near about 18 to uh, something around 35, we are seeing that chances of the probability of not survival is more, and survival is very less. And similarly, we can see. So from here, near about 60 onwards, we can see survival is very less, drastically reduced compared to non-survival, right? So not survival probability is more, and survival probability is less after 60 beyond. So this is how we can read it out from this distribution. And this is again, we can do one by one plotting. So from the Titanic data sets, we are getting age, and we are doing this plot. So apart from dist plot, this is about to deprecate. So we can use dist plot and use KDE to KDE plot to show the distribution of not survival. And similarly for survived, uh, according to age, we can see this distribution. And if we would like to combine both, as dist plot is about to deprecate, you can use KDE plot and combine both survived and non-survived, and x-axis age. You should be able to see this both graph altogether again. Now we will try to learn how we should be analyzing two categorical columns together, right? So for that, there is a tool, visualization technique, which is heat map. So we can use heat map, and this is another visualization tool, uh, which shows the relationship or a frequency between two categorical variable using color density. So if heat map by it shows wherever uh, uh, color density based on the pattern been defined, it will show from light to dark shade. And this is another visualization technique uh, from where you would be able to understand how uh, means you should be able to uh, tell some story by seeing that heat map. Okay, and it shows if we are using two categorical column, it will show the correlation uh, between those uh, combination of categories. So here again, this is a Titanic dataset, right? And here, so we would like to know how many got survived or how many got not survived in each passenger class. So for this, if I will say that Panda, create a cross tab for Titanic dataset, take this peak class and survived. So it's create this cross tab. So this is survived, this is P class. We are having P class 1, 2, 3, and passenger class 1. We are able to see 80 not survived, 136 survived. 297 not survived, 87 survived. In class 3, we are seeing very more, 372 were not survived and 119 survived. So here we are saying that in the class 3, there were more people who were not survived. But in class 1, we are able to see more people got survived. But this in this numerical, it's pretty hard to bring this intuition. But if we will put this in heat map, we should be able to see clearly. So if we want to know each classes how many survived and how many not survived, if we will use heat map and provide that data set, you will see this heat map. So this dark black shows less, and till it's moved towards light color, it shows more numbers. So here we are seeing that not survived And class 3, there were more people who not survived. And in survived in class 3 were also less. But in survived and class 1, where we are seeing a lighter set, means in class 1 there were more people compared to class 2 and class 3 who got survived, right? And in opposite to this, in class 1 there were very less people compared to survived who were not survived, right? So this is a kind of exploratory analysis we are able to do with these two columns. So again, let's consider we would like to get the percentage. This is kind of numbers, right? Now, the same thing we would like to see in the percentage form. For example, get the percentage of survival rate against each class, class 1 and class 2. Means in class 1 and class 2, what was the percentage of survival? Class 1 got survived more compared to class 2 or class 3, right? So here it will indicate, uh, so from this, what I have did that, okay, Titanic group by class, and I am getting survived, and I'm getting its means and percentage. So with this, I'm able to see that class 1 survival percentage was 62, class 2 survival percentage was 47, and class 3 survival percentage was 24. Very less. Means in this uh, passenger class, survival less ratio was very less, and in passenger class 2, survival ratio was much better, and in passenger class 1, survival ratio was more more higher than these two classes, right? So yeah, so this is again the same. I'll delete that, right? So we'll consider another use case example. For example, you have two categorical variable from Titanic dataset, sex and class, right? So want to see how many males and females were in each passenger class, right? So we will first create a cross tabulation from these two categories. So we will see this how many uh, passengers, right? So just to see that how this data looks like. So this is heat map data. So here we are creating sex and passenger class. So this is 1, 2, 3, our passenger class, and in each passenger class we are having male and female. So here we are able to see how much male and female do we have? Right. So we were seeing this is the distribution uh, between uh, Titanic sex and uh, class, passenger class, right? But to get this visualization, we created this cross table and we just passing that to in our heat map. And this is annotation, it's creating true, and this is the another formatting stuff, right? So with this, we are able to see that in uh, class 3 compared to male female ratio differences was too much. In class 2, it was not that much. Even in class 1, we see female versus male distribution is was somewhat uh, uh, more difference than class 2, right? So this is one intuition we are able to see, right? Yeah. So so just to draw that conclusion, survival count by passenger class. Uh, Here we took that survived and class uh, cross tab, and this is the number. Okay, and just we are creating heat map on top of it, and with this we are able to get this number passenger class wise survived. So survived one and passenger class one was this one, and again 136. And here we are able to see not survived, and in the class 3 were two more, much more higher, right? So yeah, now cluster map. So for between those two categorical data types, there is one more uh, uh, visualization technique which we can use. So this is cluster map. So this type of plot is useful for visualizing and identifying patterns within dataset by grouping similar categories. Means this will be similar to this, uh, uh, similar to heat map, but what it will do, it will just group similar categories together. Okay, and uh, where we should be using when we are having categorical to categorical data, and uh, it will help us to identify the relationship between two categories variables, and also shows the similarity between different categories based on how they relate to each other. So for example, we want to get a relationship between um, sibling and spouse and survived. So wherever we are having a sibling or spouse, what was the ratio of survival? So these two, sibling, spouse, and survived, are categorical. So between these two categorical, we are able to go that. So if you are able to see this table where we were having sibling, spouse, none, the survival was not survival was very more, and survival was less. When we were having one at least sibling or spouse, in that survival was more, right? When two, again it's less. 3, then survival becomes less. 4, so wherever we are having more, then survivals are getting less. It seems like if there are more people, they started uh, wondering and searching each other instead of getting freed up and uh, get out. So here we will draw the cluster map. So it shows which values are closer to each other, right? So here we are having uh, parse and survived, and between these two, we are able to draw this um, cluster map. So here you will see here these two values are more closer, right? So this is parse 2, uh, survive and not survive are more closer. Even this uh, 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 this one survive and not survive in parts 1, and here you are able to see two different uh, more differences in parts 0 and survived and not survived. Differences are two more. This is how you can read it out, this cluster map. Another visualization is pair plot. This is important. So if you are having too much many data, numerical data, right, and uh, just you want to see the how each column correlates with each column. So then you have to uh, draw the pair plot, right, a scatter plot against each, and you can understand how hard it is. Instead of how about if we will have that visualization uh, in a one go and which can tell us about that. So this is useful where we are having more numerical columns. So I'm taking this iris data because here we are having more numerical columns, right? So in this iris, we are having is petal length, is petal width, is petal length, and petal width and species. So just we will say that pair plot an iris, it will draw the visualization against each column, and you can see wherever diagonal one you are seeing this uh, uh, histogram visualization is where corresponding it is corresponding to themselves itself. So is petal length against is petal length, it's draw the histogram. Okay. Otherwise, for others, you will see is petal length to is petal length, just to minimize so that we can see it in a one go. So here you are able to see the visualization and distribution in one go, right? Against each column, right? So this is one, but you know, eh, this is the distribution, uh, petal length and this one petal width, two groups. But how about if we can see the different species group? Then we can create a hues on a species. And once we are creating this hues against the species, there were three species, right? So in this data set, we are able to see how these three species are getting um, correlated with other numerical columns, right? So species were Setosa and versicolor and virginica. So these are the three species, and this is what it shows its distribution. Again, this is a line plot. It's a numerical to numerical itself. So a line plot is used in numerical to numerical data, and it's a special case of a scatter plot. And if you add all the points of this scatter plot, you will get that line plot. So you should use uh, uh, so you should use your numerical column on an x axis, okay, uh, and x axis should be a time-based data. For example, time, month, year, and so on. For that, we are going to use flight because in the flight we are having this year, month, and how many passengers. So US flight data, and in this, uh, this is the data, right? But if I would like to see how many passengers traveled on each year, so I will group by and sum on passengers. So I would be able to see uh, as here mostly we are seeing that as the year grows, passenger grows. So this is I have to read it. It's not clearly telling it out, right? But when I will plot this uh, in uh, line plot, I'm able to see it clearly that over period of time, year increases, its number of passenger increases. So here we can see some down, but again, here from here to here, it slowed down. Not down, it slowed down. Uh, right? So this is one. And so again, for this flight data, other way we can create a pivot table. For example, here we can have all the years and months are fixed, right? So here I'm pivoting this and getting all the years on the column side and all the month on rows, and each cell shows me that how many passengers traveled. But this is hard. So my use case is I would like to see that in which month most of the travels happens, right? So if I will bring this to heat map, I'm able to see that hey, mostly in May, uh, June, July, August. In this here, right, light color is higher. In these 3 months, I'm having most throughout all the year, most of the passengers travels. And July is that peak month. June and July. July and August. These two are the peak months in the US, right? And yeah, so with the cluster map, the same things we can see, and it will correlate similar. Uh, uh, so here you can see that the July and this month and more lighter years. So 16, you'll see that 59 and 16, a higher side. And it's uh, uh, more number of passengers are getting traveled in this four region, four boxes, right? So this cluster map groups the similar features together. You'll see here, similar here, then here. So you will see the similar colors mostly has been bring together. So in a different visualization, same cluster map, we can see in where it is depicting number as well. So this is another way of plotting it, right? And again, if you would like to see this uh, heat map between survived male and female uh, cluster map. So this is how it looks like, data prepared and this cluster map. All right. So in this, we learned two things. By uni variable analysis and bi and multivariance analysis and different types of graphs techniques to do this EDA. And probably if you learn all this, you will be good to describe or bring an intuition or look the insight around the data. And I think this is more than enough for you uh, learn all those. And this is all hands-on. So you should be able to practice and get more understanding very quickly. And less jargon, more samples and examples with the different data sets here. So I hope you enjoyed this learning and we'll see you in next session. Thank you.